going to continue working on the chain rule. So remember what the chain rule said. Section 3.5.
Worksheet.
Yep, we're going to work on the same worksheet. Now, it essentially says that if y is a composite function, then the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. What this says in words is, if you have a composite function, you take the derivative of the outside rule first, and then multiply that by the derivative of the inside. So when we have that written in terms of our power rule, the derivative with respect to x of u to a power is done by bringing the power down, raising it to one power less. That's the derivative of the outside times the derivative of the inside. In terms of our 6 trig derivatives, if I've got a composite function that looks like a sine of something, you start by taking the derivative of the sine and you get the cosine. You leave the same angle there, but then you multiply all of that by u prime. In terms of the cosine, the derivative with respect to x of the cosine of u, and the derivative of cosine is a minus the sine. Keep the angle the same as it was in the original, and then you multiply by the derivative of what's inside. As far as the tangent, the derivative with respect to x of the tangent of u. What was the derivative of the tangent? Secant squared. And then you multiply by u prime. Derivative with respect to x of the secant of u. General form has the secant of u times the tangent of u, and then you multiply by u prime. Let's see, cosecant has a minus sign in front of it. It's just like the derivative upstairs. It's got the trig function back. Then it has the cotangent of u. And then the chain rule part is the u prime. And then for the cotangent, it's like the tangent derivative. Don't forget, it has a c, so it's going to have a minus sign. I'm going to have the cosecant squared of u times u prime. And then the other two functions we had were exponential functions and log functions. The derivative of e to the x is e to the x. The derivative of e to the u is e to the u times u prime. And then the derivative of the natural log of x was 1 over x. So the derivative of the natural log of u. We'll have a 1 over u in it times u prime. A lot of times I'll just write u prime over u. Save me a step, but I'm going to write it like that today so you can see the chain rule part of it. So I passed out a sheet last time with chain rule examples that we started going through, and we were on the side that said example problems. I've got about 3 of them left if anybody needs one. You have to remind me how far we got.
We were working on like 2x plus 4 up 3x.
All right.
Minus 1 to the 5th.
Okay, so that's a good place to start. Let's do our chain rule examples. taking the derivative with respect to x, brackets here, 2x plus 4 on top, and 3x minus 1 on the bottom. And all of that is raised to the 5th power. So we're going to do that using this. We've got stuff to a power. So we're going to start by bringing the power down, leave that stuff alone, raise it to 1 power less. So we're operating on the 5. 5 times blah to the 4th. General power rule. 5, keep this the same. Raise it to the 4th. Now the U prime says take the derivative inside. And inside we see a fraction. So when we take the derivative inside, we're going to use the quotient rule. The bottom times the derivative of the top, minus the top times the derivative of the bottom, over the bottom squared. So here we go. 3x minus 1. Derivative top is just a 2. And the other way, 2x plus 4. And the derivative bottom is a 3. And then all of that divided by 3x minus 1 squared. I think I will simplify this just a nudge. I'm going to multiply the stuff out on top and gather like terms. Don't you feel like simplifying today? I'm going to have 6x minus 2. Let's make sure we put this minus on both terms. This is going to be a 6x minus 12. So minus 6x minus 12 all over 3x minus 1 squared. So that'll take care of the 6x's. It's going to put me a 14 on the top, a minus 14. I'm going to put that minus 14 together with the 5. So 5 times 14 might be somewhere in the neighborhood of 70. So I'm going to put a negative 70 on top. Then I'm going to write this like this. 2x plus 4 to the 4th over 3x minus 1 to the 6th. See how I did that? Magic, sorcery. On a fraction, the power belongs to both the numerator and the denominator. So I have a 3x minus 1 to the 4th multiplied with a 3x minus 1 squared, which allowed me to do that. And writing it like this would allow me to do something crazy like take a second derivative. Let's do that. Let's take the second derivative. Okay, so let's start from here. And let's take another derivative. So to get you used to the notation, I'm taking the second derivative of this, which is the first derivative of that. So I'm going to write that out. The second derivative will be written like that of the original expression, 2x plus 4 over 3x minus 1 to the 5th is equal to the first derivative of that thing down there. Negative 70 times 2x plus 4 to the 4th over 3x minus 1 to the 6th. So the second derivative of this would be the first derivative of that. What's the plan here? How are we gonna take the derivative of that thing that I have over there?
Are there two U's? We can do that, yeah.
That's right. I have two composite functions. My numerator is a composite function and my denominator is. So whenever it's time to take the derivative of those, we're gonna look at them as quantities to a power. But what then is the outside rule? What are we gonna do first here?
There's two others. And raise it to a third. So you're just trying to do the,
But we've got to do quotient rule
Yeah.
first, right? The overall rule is a quotient, but the inside part contains composite functions. So we're gonna follow the quotient rule right here. But when it comes time to take the derivative of the top, we're gonna use that general power rule. And same deal here. Will it fit? Will it fit? Let's see. So we're gonna take the bottom, 3x minus 1 to the 6th. And now the derivative of the top. Let's keep these together. We're bringing the 4 down, multiplying with a negative 70 to give me a negative 280. And then we raise the 2x plus 4 to 1 power less. So now that's to the third. What next? Times the 2, which is the derivative inside here. So that constitutes the derivative of the top. Power down, 1 power less, times the derivative of what's inside. Now we continue on with our quotient rule. It's got a minus sign here. Now I copy down the top factor. Well, the top factor has a minus sign. So let's go ahead and make that a plus. 70 times 2x plus 4 to the 4th. And what goes here? Somebody take the derivative of the bottom for me. Here comes a 6, right? 3x minus 1 to the 5th.
what's our plus there?
I got a minus from the quotient rule and a minus from the 70. Okay. Bring the power down, 1 power less. The derivative inside now is going to give me a 3. And then all of that is divided by the bottom squared. So I'm going to take 3x minus 1 to the 6th and square it. What power will I have down here now? Higher. Raise a power to a power, you multiply exponents.
You lost me a little bit.
Where'd I lose you? From here?
Where'd you get the 3x?
This one, this is
Oh,
the
it's
bottom.
still the bottom. Okay, yeah.
That's the derivative of the top. Power down, 1 power less, derivative inside. And then minus the top. Well, the top had a minus sign on it, times the derivative of the bottom. And this stuff here is the derivative of the bottom.
Where's there another 2?
Here?
Yeah.
That's the derivative inside.
You just attached it.
Yep. And over here, take the derivative inside.
Okay.
So when it comes time to do the derivative of the bottom.
You always do that?
You always must do that.
When you're, instead of like, is that one we did at the very end, right?
Did it at the very end.
Maybe not. Oh, you did it that way. Okay. I did it different at the end, outside of it. Outside of the quotient rule. Would that not work?
It has to be only on that particular term. So this 2 has to belong to the first term, and this 3 has to belong to the second term. Yes. That is the second derivative. That's the second derivative of the original expression, which is the first derivative of my first derivative. All right, let's simplify. I'm going to look in front of the plus sign and put my little dangling terms together, the terms that don't have the parentheses and the power on them. So I'm going to multiply 2 with a negative 280 And I'm going to get negative 560. Then I've got this factor to the sixth, that factor to the third. Do the same behind the plus sign. Take all the terms that don't have the power on them, which would be the 70 times 6 is 420. 420 times 3 is 1260. I have plus 1260. Then I have a 2x plus 1 to the fourth, or 2x plus 4 to the fourth, and a 3x minus 1 to the fifth. Find all that? What can I take out?
You got 3x plus 1, or is that?
I can take out a 3x minus 1 to the fifth power. I can take out a 2x plus 4 to the third power. Oh, and I have to bet there's some common factor between the 560 and the 1260. But I don't know what it is, and I really don't care. Where did the 1260 come from? 70 times 6 is 420, times the 3 on the end gave me the 1260.
I just found confused myself.
Where did I confuse you?
I just found confused myself. I confused myself and
Unconfused yourself. Okay, but instead of factoring, I'm going to shortcut it. I've got a 3x minus 1 to the 12. Here I've got it to the 6th. There I've got it to the 5th. What's the most that the three of those have in common? So I'm going to knock out a 3x minus 1 to the 5th in all three slots. So it's gone from here. I took 5 of these away, so there's only 1 here. And I'm going to take 5 of those away, so there are 7 of them there. Then in the next step, I'm going to pull out the 2x plus 4 cubed. Let's see what's left. I've got the negative 560 with the 3x minus 1. Then I've got plus 1260 times 2x plus 4 to the 4th. Oops, I would pull 3 of them out. So that's 2x plus 4 to the first. So plus 1260 times 2x plus 1. What did I say to the first power?
Yes.
2x plus 4. Thank you. And then on the bottom, 3x minus 1 to the 7. So if we can clean up what's in those brackets right there, I think we'd be finished. Those numbers look so big, but I started this, I may as well finish it. Let's see, when I multiply those two together,
Question.
yes,
So even though you have like 3x minus 1 to the 7th on bottom and just a 3x minus 1 raised to a lower exponent on top, you can't cancel off the top one.
because
Addition.
it's not
fair.
common.
Wait, what happened? I thought we canceled the 2x plus 4.
I took 3 of them out. There's nowhere to cancel them. So the best I can do is pull them out.
Okay.
So I pulled it out. Okay, so I'm going to distribute here and I get negative 1680x plus 560. And then here I get plus,
You can pull 70 out.
I can.
Yeah.
That help?
I mean, you can start in front of the first term.
I'm going to take it out at the end then, because I've already committed myself to this. Let's see, this is going to be 2520x. Oh, gosh. Plus, I don't know, maybe somewhere in the neighborhood of that number. I'm multiplying 4 times 1260, maybe I get 540. Maybe. So my final answer might be right about here. 2x plus 4 cubed. All right, I gotta take 2520 and subtract 1680. Here's my public arithmetic. 840. That'll be a positive 840. X. And then 560 plus 5040 is 5600. So I lied. I'm not going to take out any 70s. I'm just going to leave it in there. Doesn't matter room.
Second derivative.
That's the second derivative. It was a lot of work. I thought we'd start out just with a busy problem here. You didn't pull any muscles, did you?
Maybe brain muscle.
Brain muscle? I need snap. Was your idea to do the second derivative? I can remember you clamoring for
Was
it.
it now?
You said, we simplified it. Let's do another derivative.
Yeah.
And I thought you said, good. Yeah, I'm glad you remember that. Okay, I gotta erase all this stuff so I can do another example. How do you even read the next example out loud? What does it say? How do you read that?
Sine 4x.
That's right, it's the cosine of the sine of 4x. So the sine of 4x is the inside, and the cosine is the outside. It's not a product rule, it's a composite function. But again, it's the cosine of the sine of 4x. You've got a nested chain rule thing going on here. So the parentheses are going to emphasize that. We're going to start outside. This is the cosine of u. So the cosine of u is minus the sine of u times u prime. So all of this right now is our u. So we take the derivative of the cosine and get minus the sine of u. And now we're inside. We got to multiply by the derivative of this. But that's another composite function. We start by taking the derivative of this trig function. And we'll get the cosine of that same angle. And now we have to go inside the last parentheses, take the derivative in there, and that gives us a 4.
So you took the derivative of the outside and then the inside and then the derivative of the inside.
That's right. That's right. Our way in. And now this is not the same as sine squared. So there's really not much we can do to simplify this other than take that 4 and put it out front.
So you can do like negative sine squared 4x, right?
No, that's
No?
not, that's the sine of the sine. So it's not multiplication. I can't write that as a sine squared.
Can you group the sine and the cosine for us since they have the same?
But this is inside, so that's untouchable. Like I said, the only thing you can do to simplify this is take this 4 and put it right here in front of the sine. And that's not worth wasting ink over. Okay?
That must work out down there.
Okay, the next one. Oh boy, we got quite a mess going on here in the next one. Let's see, we've got an x squared plus 3 to the 6. Then we've got another quantity that's squared. It's an e to the 2x plus the cosecant of 4x, and then close those parentheses and square it.
This problem is for the people who left their glasses at home.
Is it? All right, real big. That means I gotta erase them so it can fit it. We're gonna take the derivative of this guy.
Look at this as power rule. Or
The first thing you see is a product. So you're gonna do a product rule on this. But when it comes time to take the derivatives of the first or the second one, that's a power rule. We're gonna do a first and a second deal.
It's 2EX. 2EX? A e to the AX is equal to, e to the AX is equal to A e to the AX.
Derivative e to u is e to the u times u prime.
Yeah, just like that.
First times the derivative of the second. Second times the derivative of the first. The first step is just to copy down x squared plus 3 all to the 6th power. Now you got to look at that second factor as being blah squared. You bring the 2 down, leave that alone, raise it to the first. Bring the 2 down, keep the e to the 2x plus the cosecant of 4x, then raise it to the first power. Now we have to take that and put its derivative right here. So here's the derivative of e to the u. It's e to the u times u prime. All right, next I'm going to take the derivative of a cosecant. So I have a minus. What's the derivative of cosecant? Cosecant cotangent of the 4x. So minus cosecant of 4x, cotangent of 4x. But now I've got the one more term here to tack on. And it only goes on to this one. Doesn't belong to the e, it only belongs to the cosecant. Okay, so that comes from the derivative inside. So we're here. Yes, sir.
You said the 4, because it was the derivative inside the trait function. But like when I'm looking at that, so the 4 is not attached to the 2e, but in order of operations, would it not still fall within that parentheses?
It is within the parentheses. It's not. So my point is it goes here and not here.
Oh, okay. Oh, okay. So
Okay. All right, so we're done with the second one. So now let's go back to the original problem and copy down that second factor. E to the 2x plus the cosecant of 4x. And it was squared. And now we're taking the derivative of this one. So compared to the last one, this is going to be kind of quick. Bring the 6 down, the 1 power less, multiply by the derivative inside. Bring the 6 down, 1 power less, puts me to the 5th power, and then the derivative inside. I'm not going to simplify that. You're going to like a derivative that takes up 2/3 of your board. There's no way to make that look any prettier. Yes. Your arrow means I'm going inside now. That's the derivative inside. Right, I've got to have the derivative inside there. So this was the derivative of the outside times the derivative inside. But when I'm taking the derivative inside, I've got another derivative inside. Same deal here. Second factor, derivative of the outside times the derivative of the inside. Yes, sir.
Can you explain to me just real quick that e to the 2x, the derivative of that just becomes 2? So is it like a normal power rule, but you don't?
It's not a power rule. The derivative of e to the u
I'm losing it.
is e to the u times u prime. So the derivative of e to the 2x is itself
Oh,
times the derivative of the power. Okay. So I finished my share. Now it's time for you to do your share. Flip them over. And I want to see, why don't you work the first 2 of them? And then I'll catch up and check them. And we'll do these like maybe 2 at a time. So try the first 2. I'll put them on the board for anybody watching at home.
set on the back side of the
On
street.
the other side says chain rule. Those are yours. Problem number 1.
They just went straight in, didn't they?
Don't simplify. Don't simplify. Derivative of tangent is secant squared. Yes. The tangent of u is secant squared of u. So don't simplify unless you're feeling bold and brave. I'll try to beat that out of you. More room here because we get your product rule on that, right? we ready to check 1 and 2? All right. So here we're gonna label our derivative f prime. And my plan is first times the derivative of the second times the derivative of the first. I'm just gonna copy down the secant of x to the fourth. So the derivative of the natural log of u is 1 over u times u prime. So 1 over 9x minus 8. And then I'm going to put the u prime right here. Is that okay? So what is the u prime? It's 9. 1 over u times u prime. Now we're going to copy down second factor behind the plus sign, the natural log of 9x minus 8. Okay, and we're going to take the derivative of the secant of u. The derivative of the secant of u, the secant u, tangent u times u prime. So I've got a secant of x to the fourth, tangent of x to the fourth, and now 4x cubed. That's inside there. Okay? What about it? Did everybody get that one?
So that's the answer.
That's the answer. That will
Okay.
simplify.
Where does the chain rule come in?
They're all chain rules. Right? This was a chain rule. I'm taking the derivative log of u. This was a chain rule. I'm taking the derivative of the secant of u. Right? Here I have the derivative of the natural log of u. I wrote it as u prime over u. And here I did the derivative of the secant of u. It's the secant of u, tangent of u times u prime.
So it's all, the whole thing as far as the rules, like inside.
Inside is the chain rule. That's right. Okay, so here we've got to think of the 3x as being a 3x to the 1/2. And so I've got a quantity to a power. So we'll take the derivative here, bring the power down, 1 power less times the derivative inside. Bring the power down, 1 power less times the derivative inside gives me a 3. Here, the derivative of a tangent is a secant squared. So I'm going to get a secant squared of x squared. And now I've got the u prime term. So now I'm in the parentheses here, taking the derivative of x squared. And we get 2x. Is that okay? Is that what you got? All right. So try me the next two. Don't simplify again. Just try the next two. You got two quotient rules, but warning on number 3, the numerator is a product. So when it comes time to take the derivative of the top, make sure you pay attention to that.
Down 3 is weird.
This here, take time. That's the natural log of the tangent of t.
Looks like you have a quotient rule inside of a quotient rule.
I have a product rule inside of the quotient rule.
But then the bottom,
That's not a product, that's the natural log of the tangent.
right,
You say because of the it's like,
yeah, the derivative of the natural log is like 1 over.
Right, but that's really not a quotient rule, right? The
Oh,
quotient
right,
rule
okay.
tells me how to take the derivative of h.
I see what you're saying.
We're gonna go bottom times the derivative of the top minus the top times the derivative of the bottom. Bottom squared. But when we're doing this part, in this example, we've got to do the first times the derivative of the second plus the second times the derivative of the first. So here we go. First, copy down the natural log of the tangent of t. And now I've got to do the derivative of the top, but it involves two terms. So let's put them in brackets. So I've got to do first times the derivative of the second. The first term is just a t. Now what's the derivative of the cosine of 5t? Minus the sine of 5t times the 5. I'm gonna put the 5 right here. That's the first times the derivative of the second. Now the other way, the second cosine of 5t times the derivative of the first. Where that t is just 1. So I'm not going to write it. Just go block that off.
If that t was a number, then would it still be a product rule on top?
No, if it's just a constant, then it's constant times a function. All right, I need some more room here. I got to copy down the top. T cosine of 5t times the derivative of the bottom. So that's a natural log of u. So we get 1 over u tangent of t, not 5t. 1 over u times u prime, and I'm going to put the u prime in the numerator. What's the derivative of tangent of t? Secant squared of t. And then inside here, the derivative of that t is just 1. And all of that divided by the bottom squared. Need to go back and point anything out?
What's about with the negative, or with this, cosine of 5t? When you get the derivative, you get this negative sign.
Right.
Yeah, yeah. But you multiply the 5 out because it's,
Inside. The cosine of u is minus the sine of u times u prime. How are we gonna do this one? We do quotient rule. Bottom times through the top minus the top times through the bottom of the bottom squared. Now those are just individual terms on the top and the bottom, so we don't sneak in any product rules or anything like that. So we're going to need to know how to take the derivative of e to the u right here. And we're going to need to know how to take the derivative of the cosecant of u right there. You tried it already? Bottom is the cosecant of 5x cubed times the derivative of the top. It's the derivative of e to the negative 3x. E to the negative 3x times derivative upstairs. U times u prime. Minus sign from the quotient rule, then the top term. And now the derivative of the bottom. What's the derivative of cosecant? Minus cosecant of the same angle, so I need the 5x cubed, times the cotangent of the same angle, times 15x squared, which is the derivative of that angle. And then all of that is divided by the bottom square. So I usually put the squared right next to the trig function.
Would it be wrong to say put brackets around the trig function and then put square?
Nope, would not be wrong.
Not be wrong.
Now take a look at that above. The terms are separated here, and each of the terms has a cosecant of 5x cubed. So we're able to cancel one now. There's always going to be one that looks alike there, but it's the presence of this one that allows me now to cancel. Okay, so I'm going to simplify this just to show you that. Since there's one here and one there, then I can take one of these out. Like that. Okay. So now it's gone. We get -3 e to the -3x. I'm going to put these two minus signs together to give me a plus. I'm going to put the 15x squared way out front here, then the e to the -3x, then the cotangent of 5x cubed, and then the denominator, which is no longer squared. And so there's not much you can do from beyond that. I just want you to be aware that it's a common factor if it's in front of the minus sign and behind the minus sign.
When you're factoring out if there's a negative, the negative stays, but you just factor out the term behind it or in front of it. Meaning like negative, cosecant.
Right, I put those two minus signs together here. All right, that puts us at bottom two, nope, middle ones. All right, number 5. Take the derivative with respect to x of the cotangent squared of 7x. So I need you to read this as if it were here. This squared is the outside rule. It's way up here. So your job is to take the derivative of u squared.
Square.
Power down, raise to 1 power less, multiply by the derivative of what's inside. we check it? We check this one? That one? That one? All right, so I said we're starting out here. 2 comes down, leave it alone, 1 power less. That's the power rule. Now that's for the first power. Now we're inside taking the derivative of a cotangent. So that's a negative cosecant squared. Keep the 7x there, and then multiply by 7. Okay. So here you can put the 2, the minus sign, and the 7 together out front. We get a negative 14 times the cotangent of 7x times the cosecant squared of 7x. Part okay with you? And for this one, you did the product rule? First times the derivative of the second, second times the derivative of the first. The first is just e to the x squared plus x. And now we have to use the log of u derivative formula. 1 over u times u prime. Those 3's in there will cancel. Then the other way, plus the second, times the derivative first. So we can take the derivative of e to the u. We'll get e to the u times u prime. X. And then u prime, 2x plus 1. Happy with that?
You don't have the x squared plus x down.
No, it doesn't come down. The derivative of e to the u itself times the derivative of the power. Itself times the derivative of the power. So the next one's a power rule again. Number 7. When you see the power next to the trig function, train yourself to think about the quantity to that power. So that's the same as saying this. Whole thing is cubed. This part is a power on the whole trig function. It's not a power on the angle, it's on the trig function. We're done.
I think I did it.
We're not going to bring the 3 down, leave that alone, and raise it to 1 power less. Right? Then what? Where the sine is a cosine. The angle alone. Now I go inside and take the derivative of the angle.
So are there gonna be some problems that we have where like?
There's more and more and more and more. Yeah, we can.
derivative of like the inside is gonna end up being a product rule.
Could be. I mean, that'd be pretty brutal, wouldn't it? But I want to see if you can, let's see, that was 7, here's some more. See if you can tell the difference between stuff like this. See the difference? Powers here, with or without these parentheses. If I write this without the parentheses, that power is implied only to be on the x and not on the cosine. With or without the parentheses here, the power is on the cosine. So you're going to do this one as the cosine of u, and this one you're going to do as a u squared. Think of that as the cosine of u, and this one you're going to think of as a u squared. You got it? Derivative. So using the cosine of u formula, the derivative cosine of u is minus the sine of u times u prime. So minus the sine of 5x squared times my u prime is 10x. Minus the sine of x squared times 10x. And this one, we got to think of it as a quantity squared. So bring the power down, raise it to 1 power less. Now times the derivative inside. Now I've taken care of this, now I'm inside. And first take care of the cosine, and I get minus the sine of 5x. And now I'm going to go in here and take the derivative of that and get me a 5. 5. Yes, sir.
For the negative 10x sign,
Mhm.
if you hadn't have moved the 10x to the front, you have combined like the negative sign and 2 with the cosine with the 5 at the end, or no?
Not sure which ones you're combining.
What was that about all
This is separate. So I'm not combining anything here. Nothing
Yeah.
joins together here.
You're not combining anything to the right of the plus sign with anything to the left.
Because I don't have any common terms. This is a cosine times a sine, and that's a,
Fine.
there's not a cosine times a sine there. That's x times a sine.
Okay.
Yes.
So on the right side, would you like bring the negative to the front and combine the 2 and the 5?
Yeah. Here's what we can do. We can write that as negative 10x sine of 5x squared. This 2 and that 5 can go together, and that minus sign.
Okay, so that's what I was talking
So
about.
that'll be a minus 10 Cosine of 5x, sine of 5x. That what you were talking about?
Yes.
Yes.
Just,
The
I was
terms
just trying to,
here can go together.
I was just trying to combine the negative sign of the first one before you move the 10x over.
Like that.
Yeah, but on the left side of the plus sign.
Yeah, but I can't
That's where I
do
missed it.
anything. This guy's separate,
Right. That's
right?
what I
That's an
missed.
x sine x, and that's a cosine times a sine. Okay? Did you both have the same thing?
No, mine was kind of identical. So I just did a negative.
Yeah, that's fine. Yeah, that's fine. But you probably put the parentheses so it looks like multiplication and not subtraction. And that's why I put it in front, so then I can see the multiplication. Okay, you ready to write an equation of the tangent line? Right, equation of the tangent line 2, y is equal to e to the negative 3x sine of 4x at point where x is 0.
Okay, so it's
Product.
It's a product rule. So one of the things you need is the y value when x is 0. Does anybody have that yet? Since the sine of 0 is 0, the y value is 0. Right, sine of 0 is 0, e to the 0 is 1. So I have 1 times 0 is 0. Then the slope of the tangent line is the derivative at that point. The derivative involves the product rule. So I'm going to do it again in this order. Here I'm going to use the sine of u derivative. Here I'm going to use the e to the u derivative. Prime is e to the negative 3x. The derivative of the sine of u is the cosine of u times u prime. Right? Cosine of 4x times 4. Then the other way, copy down the sine of 4x. And now we're taking the derivative of e to the negative 3x. What'd you get? Good. Now let's go ahead and put 0 in for x. This is going to be e to the 0. This is going to be cosine of 0 times 4 plus the sine of 0 times negative 3 e to the 0. Like before, the sine of 0 is 0, so all of that is 0. What's the cosine of 0? That's a 1. What's the e to the 0? 1 times 4, y prime is 4. So when we use y minus y1 is equal to m x minus x1. Both my x1 and my y1s are 0. So we just have y is equal to 4x. Find all points where the tangent line is horizontal.
So you just said it's equal to 0 instead.
Well, we'll give you a different problem. Let's go with x squared times 2x plus 3 all squared. I know the tangent line is horizontal. You're going to take the derivative and then do what with it? Sign towards 0. Take the derivative and set equal to 0. So you're going to have to do a little polynomial factoring maybe. So let's make sure you get your derivatives correct before we start doing the factoring. And do the product rule to get g prime. So we copy down the first one, take the derivative of the second one. So when we take the derivative here, we start up here. 2 times all of that to the first power times the derivative inside gives me another 2. Then we go the other way, copy down the second factor, 2x plus 3 squared times the derivative of the first gives me a 2x. With me? I'm going to simplify a little bit. I'm going to take this 2 times that 2 and put it in front of the x squared. So I'm going to write my first term as 4x squared times the 2x plus 3. Over here, I'm just going to swap places with the 2x and the 2x plus 3. And I don't want you to multiply this all out. We're going to try to factor from here. Multiplying out is not going to help. You'll get some third-degree polynomial. Third-degree polynomials are hard to factor. But this one's already partially factored for us. If I look here, I've got a common factor of 2x. And if I look here, I've got a common factor of 2x plus 3. So I'm going to pull out 2x times 2x plus 3. So when I pull out a 2x from this, I'm left with another 2x right there. And I've already pulled that out. So I'm now at the plus sign. I pulled out the 2x, I pulled one of those out. So I've got a 2x plus 3 left. Okay. So now in the brackets, that adds to 4x plus 3. So I've got 3 factors. There will be 3 places at which the derivative is 0. G prime is 0 when each factor is 0. First factor is 0, gives us x is 0. Second factor is 0. Subtract 3, divide by 2, gives us x is negative 3/2. And the third factor is 0. Subtract 3, divide by 4, gives us x is negative 3/4. Okay? That's why we have to practice factoring, so that we can do little tasks like that. Okay, let's end with another day. You have some papers up here. Those of you who turned in some paper homework. We've got Autumn, Marley, Jonathan, Cooper, Case, Austin, and Angela. Case. Well, you turned into, I'm going to turn right into. Thank you. One more. Madeline, I got one of yours up here too, Luke.
We can.
Yeah. So practice, practice, practice. Make yourselves really, really good at chain rule and simplifying. Thank you. Thank you. Thank you.
Bye-bye.
You all good, Nathan?